All right, we're taking another look at word problems here, quadratic word problems, day 2. We have our graphing calculator handy. Again, you guys should be using one. Again, pause this to do your graphs. If you're unsure, make sure you guys are watching it, and this is to help you guys. When an arrow shot into the air, its height h in feet above the ground is given by this equation. H equals negative 16t squared plus 96t plus 5. T represents time in seconds. So t is going to be your x-axis here. H is going to be your y-axis. Graph h on the axis to the right. For all heights above the ground, h equals 0. Okay, so I go to y equals negative 16. Remember, we're using x instead of t, plus 96x plus 5. Again, I could hit graph, but it's not going to show up on mine. On the computer, you may be able to zoom, even with your fingers. But I'm going to hit second graph to look at my table. I'm going to create my table. Again, t and h. 0 is 5, 1 is 85, 2 is 133, 3 is 149, 4 is 133, 5 is 85, 6 is 5, and then 7, I'm going to write it, but if you notice it's negative. We talked about what happens in a word problem when we can't have negative, because it's going to hit the ground and then it would stop, right? So we have 20 boxes here, so I go as high as 149, so I'm going to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 150. I do have some wiggle room here. And then here I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7. So I'm graphing where h is above the ground. So again, all of those values here, I'm not going to graph 7 because it goes to negative. So 0, 5 is right there. 1, 85, 50, 60, 70, 80, 5. 2, 133, 110, 120, 130, 133. 3, 149, all the way up there. 4, 133, here's that symmetry there. 5, 85, 6, 5, and then it hits the ground. So I'm going to connect. Remember, it's a parabola here, so it's going to go up and down. Okay, no arrows because it's a real-world problem where we started at 0 seconds, and then once we hit the ground, we were done. What is the maximum height of the arrow? So I'm looking for an h value. The maximum height is my vertex, 149 feet. How long does it take before the arrow starts coming back down? Okay, it went up, it reached its highest point, and then it came back down. So how long does it take? 3 seconds. To the nearest whole number, determine the value of t where the arrow hits the ground. So we looked at this yesterday as well. Is 5 closer to 0, or is negative 107 closer to 0? So 5 is closer to 0, so we're going to say 6 seconds. Suppose the arrow hits a tree after 1.5 seconds, stopping its path. How far up the tree would the arrow hit? We could do this one of two ways. We could approximate it by looking at 1.5 here, go up where it hits, so it's approximately 105 feet. Approximate, A-P-P-R-O-X. Or I can get the exact height by plugging 1.5 in for t. Remember, it's time. 1.5 plus 5. So I'm going to do this on the main screen. Let's see how close we are with our guess here. Negative 16, 1.5 squared plus 96 times 5 times 1.5 plus 5. Close. 113 feet. So this is the exact value. My 105 was approximate based on the graph here. Moving on, again, we're going to try pausing this so you guys can try it here. Obviously, hit play again once you're ready. Or if you're struggling here, an artist drew a rainbow mural on the school cafeteria wall. Its outer boundary can be represented by a parabola with the equation y equals -1/2 x squared plus 6x. Y is the height, x is the width. Use your calculator to sketch the graph. Okay, so remember, we have only quadrant 1. So we have our x, we have our y. I'm going to go to y equals -1/2 x squared plus 6x. I may actually be able to see this one on my graph. Let's see what it looks like. Okay, not quite. But I am going to look at my table here. 0, 0, 1, 5.5, 2, 10. I'm just going to kind of, 6 is 18, 10 is 10. I did a bad job. And 12 is 0. So disregard that. I'm going to put it here. X, Y. 0 is here, and it goes all the way to 12. 6 is at its highest point. Just want to sketch, so 15. So its highest point was 18. Its lowest point was 0. And I would, if I had a graph, I would be plotting these points. But I know it goes up. It's a rainbow here, and goes back down. Determine the maximum height and the maximum width. So the maximum height is your y value, the maximum width is your x value. So what is this value here? This value is 6, 18. So that means the maximum height is 18 feet, and the maximum width is 6 feet there. Okay, and one more. Sorry, 2 more. During a tropical storm, an antenna broke loose from the roof of a building 144 feet high. The antenna's distance d in feet above the ground after t seconds is given by d equals -16t squared plus 144. -16, again, x squared plus 144. Graph from 0 to 3, label t and d instead of x and y. T and d instead of x and y. I'm going to use second graph. 0, 144, 1, 128, 2, 83, 0. Let's see, I go all the way up to 144. I'm going to go by tens again. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 1, 2, 3, 4, 150. So at 0 seconds, 1, 2, 3, it was 144. 1 second, it was 128. 2 seconds, it was 80. 3 seconds, it was 0. Remember, no arrows here because it's a real world problem. Once the antenna hits the ground, it's done. Okay, after how many seconds will the antenna hit the ground? 3 seconds. And if you notice, if we were to graph this whole thing or you use your calculator, yes, there is the other part of the parabola, but we don't see it because we don't go back in time here. Using the table on your calculator, determine the nearest tenth of a second when the antenna will reach a height of 100 feet above the ground. Provide 3 lines of your table to justify your answer. Okay. I'm not going to have you guys do this, okay, because if you guys were all in person and I was there, I would have you guys do it. I would show you how to change it. What we're going to actually do is look at the table, the graph itself. So 100 is here. So I'm going to go, that's where I hit 100. So I'm going to approximate here. And it's not quite half. It's a little bit more than half. So I'm going to go ahead and say it's either 1.6 or 1.7 seconds. Okay, and the last question here. A slow pitch softball is pitched to a batter. The ball follows a path in which the height h is given by h equals -2t squared plus 8t plus 3. T is time in seconds elapsed since the ball was pitched. Draw a sketch of the graph. Okay. Go to y equals -2x squared plus 8x plus 3. Second graph, let's look at our chart here. 0, 3, 1, 9, 2, 11, 3, 9, 4, 3, 5, negative 7. Remember, I'm not going to graph any negatives, because once that ball hits the ground, it's done. Quadrant 1, T and H, 0, 1, 2, 3, 4, 5, and it went as high up as, even if I went by 5s, 5, 10, 15, 0 it was 3, 1 it was 9, 2 it was 11, 3 it was 9, 4 it was 3, and then 5 it's down here, but I just know that it's going to hit the ground in between 4 and 5 seconds. At what height was the ball released from the pitcher's hand? So this is its starting point. At 0 seconds, how high was it? 3 feet. What is the maximum height? We're looking for, oh, no. The maximum height is the vertex, 211, so that means 11 feet. The batter hit the ball at the same height in which the pitcher released the ball. How much time elapsed until the ball was hit? Which height is given? Interesting for that one. I would say 4 seconds, only because that's where it started at 3, and it said it was hit at the same height there, so 4 seconds. So that one was a little bit of a tricky question there. Okay, again, follow along if you need to go back. Make sure you guys are graphing this as well. The people in person will be getting a paper copy. The people at home will have, you know, the PDF, and you could go on Cami here. So again, hopefully this helped you guys. Keep up the good work, and we'll see you soon.